Let us see the next compound, which is ozone, O3. We know ozone is an allotropic form of oxygen which exists above 20 kilometers from the Earth's surface. It forms a protective layer around the Earth, and it prevents ultraviolet radiation which are coming from the sun entering into the Earth's atmosphere. So it's very useful, but what is most important is you understand its preparation and its decomposition. Now, if we see its preparation, what we find is it is prepared from oxygen. This is how it is prepared, and the electric spark or electric arc is the one under the influence of this, it gets changed to ozone. The enthalpy of this reaction is plus 142 kilojoules per mole. Entropy of this is negative, so we can understand the free energy of this reaction will be again positive. So this is a non-spontaneous reaction which takes place under the influence of the highly energetic radiations and electric arc at the upper atmosphere, that the oxygen which is there is getting converted into ozone. Now what you need to understand is that its concentration cannot go beyond a certain limit, because definitely then this process again goes back. What this we can understand in its properties. Let us first study its properties, then I will tell you how this preparation is getting affected. It's a now let's talk about its properties in terms of a gas. It's basically the pale blue colored gas which can be solidified or liquefied to a pale blue solid or a liquid. Now it is as such is not having any harmful effects on us. If inhaled below 100 ppm concentration, it's having no harmful effect, but when inhaled above 100 ppm concentration, then it causes nausea and headache, because the rate of oxidation becomes, I think that's that gets increased. Then let's talk about its property. Now if we see its reverse of this reaction, what we find is this ozone will change into oxygen, 3 molecules of oxygen. Now, since the delta H of this one was positive, of course the delta H of this reaction will become negative. The delta S will become positive because 2 moles are getting changed into 3 moles, and this will make this process delta G negative. It means what? The decomposition of ozone is very much spontaneous. That's why we cannot store this ozone for a longer time. It's usually prepared in C2 because it changes to oxygen and its decomposition becomes explosive in nature. And that is why a lot of ozone, if it is there, it's getting automatically converted into oxygen. So that's why in the nature this cycle has to be there, and if it gets disturbed by any means, that is what is leading to the depletion of the ozone layer. Now let's further talk about this one. The next thing, we know in the properties, the ozone splits up into oxygen and nascent oxygen, and this nascent oxygen is basically used for the oxidation purpose. That is why when lead sulfide is exposed to ozone atmosphere, gets oxidized to PbSO4 and oxygen. That's a very important one of its reaction, and this is the one which is being used to restore the original colors of the ancient paintings, which gets what? Darkened black, they becomes black due to the reaction of a sulfur with lead, which forms lead sulfide, black color. But those ancient paintings, when kept in an ozone atmosphere, they get changed into white or colorless lead sulfate and oxygen. Similarly, we can find out quantitatively the amount of iodide ion in any aqueous solution by what? Passing ozone, because ozone oxidizes iodide to iodine, and it forms OH minus and O2. Now this iodine can be quantitatively titrated with sodium thiosulfate solution, and we can find out how much of ozone iodine is there, and from which we can find out how much of iodide was there in the original aqueous solution. So it is used to determine quantitatively the amount of iodide ion in any aqueous solution. That's another, it's one of its use in oxidation reaction. Then you need to understand that the natural when we uses the fuels like petrol and diesel, the nitric oxide is the one which is the major pollutant which is being thrown out of these from these fuels. Now, from the exhaust of these cars and the trucks, others. Now, this NO, when it goes up, combines with oxygen or ozone, and it gets oxidized to NO2 and this oxygen. This NO2 comes out in the form of nitric acid, in the form of acidic rain, and this basically pollutant is causing the main depletion of the ozone layer because it's eating up the ozone. Now, let us study its structure. In this, what we find is one of the central oxygen is being doubly bonded with another one oxygen and is forming a dative bond with another oxygen. So that's why what we find is, if we put up the lone pairs like this, we have a resonance in its structure, single here, double here. This is how it shows resonance. So this is what we have, the ozone.